Hi, my name is Andrea Sanchez and I'm from 11th grade. Welcome to my science fair project, Glow from Scratch. Have you ever wondered how a light bulb works? In this project, I explored that question by making a light bulb at home using simple materials. I tested different filament materials to see which one glows the brightest. Let's dive into the science behind it. With the background research, a light bulb produces light through a process called incandescence, which means an object emits light when it gets hot. Inside a traditional light bulb, there is a thin wire called a filament, usually made from tungsten, that heats up when electricity flows through it. This happens because of an electrical resistance. When electrons flow through the filament, the resistance slows them down, causing the filament to heat up and glow. Materials with high resistance glow better, while those with low resistance, like copper, may not glow at all. To prevent the filament from burning out too quickly, real bulbs have a vacuum or an inert gas inside. In my project, I used a glass jar to simulate that environment. For my experiment, I tested three different filament materials: pencil lead, steel wool, and copper wire. I wanted to see which one glowed the brightest and for the longest time. My hypothesis was if I use a filament with higher resistance, then it will glow brighter and last longer when electricity passes through it. I expected steel wool to perform the best because it has higher resistance compared to pencil lead or copper wire. Here's the procedure to the experiment. Put on safety gloves and goggles. Attach one end of a wire to the positive terminal of the battery. Attach another wire to the negative terminal of the battery. Secure a piece of pencil lead between the three ends of the two wires using alligator clips. Place inside the glass jar. Complete the circuit and observe the filament heating up and glowing. Data collection. I tested each filament 3 times and recorded the glow duration in seconds, rated the brightest on a scale of 1 to 5 and noted any observations. Here's what I could find. The first filament material is pencil lead, and in the first trial duration it lasted 9 seconds. In the second trial duration it lasted 10 seconds, and in the third trial duration it lasted 11, with an average duration of 10 seconds. The second filament material is steel wool. In the first trial duration it lasted 20 seconds, in the second trial duration it lasted 19, and in the third trial duration was 21, with an average duration of 20 seconds. The third filament material is copper wire, and in the first trial duration it got a 5, in the second a 4, and in the third a 6, with an average duration of 5. My results showed that steel wool glowed the brightest and lasted the longest with an average duration of 20 seconds and a brightness rating of 4. Pencil lead glowed moderately but broke quickly, while copper wire barely glowed because of its own low resistance. These results support my hypothesis. Filaments with high resistance glow brighter and longer. In conclusion, I learned that the resistance of the filament material plays a key role in the brightly and how long it glows. Steel would work best because its high resistance caused it to heat up more, producing a light-lasting glow. This experiment helped me understand how real light bulbs work and why certain materials are used in them. Thank you for watching my Glow from Scratch project. I hope you enjoyed learning about the science of light and electricity as much as I did.